Okay, today's November 3rd, 2011. We're starting lesson 4.1. Okay, so again, lesson 4.1. We're going to start relating standard form of a quadratic expression, which is written as f at x is equal to a times x squared plus b times x plus c. And we're going to relate it to our vertex form, which we were using for our assignment, which is f at x is equal to a times x minus h squared plus k. Now, we're pretty familiar with our vertex form. We used it in the assignment. We're going to go through a couple examples of graphing them and putting up all the points, and then we're going to go on how to go from vertex to standard form of an equation. So, let's work on our first question. So, to start off, we need to be able to recognize what form we're in right now. Does anyone know if this is standard or vertex form? This is your vertex form. Okay, so in our vertex form, we're used to looking at an equation where the very first variable is a. Our h value deals with transforming or moving the equation left and right, and our k value deals with moving the parabola up and down. First thing we're going to do is try to recognize which variable is what number in our equation. So, what is our a value in the equation below? Okay, so we know that a is equal to -1. That's going to tell us quite a bit. What first we're going to do is just label them. What is our h value? 20. So h is 20, and our k value is 400. Okay, so that already has given us a lot of information in terms of graphing this. If we go to graph this, we can already tell what the vertex of the equation is, hence why we call it vertex form. The x value of the vertex is related to our h, okay? And in fact, if you include the sign in front of it, it's opposite of what's in that bracket, or what exactly we took out. So what is the x value of our vertex? 20, that's right. The x value of our vertex is 20. What about the y value of our vertex? It's related to k. Our k value is 400, so whatever the k value is, that is the y value of our vertex, okay? So we found some information already. So we have the vertex of our equation. That's one piece of information. I would also like to know if this equation opens upwards or downwards. It opens downwards because our a value is a negative number, okay? So theoretically, let's say we're drawing a parabola on the side, actually. Okay, so as we go to make this graph, so we've put up our x and our y axis. We're going to try to draw a diagram of exactly what we're going over. So the vertex of our equation, we know the x value is positive 20. So we're going to say this is positive 20, and our y value is 400. So we're going to say this is 400. We know our vertex is going to be there. We also know because the a value of our equation is a negative number, in fact it's -1, we're going to have a parabola that's opening downwards, okay? So this is just an estimate right now. We're going to actually try to find some of the other points in this parabola, okay? So we know it's opening downwards. So our parabola, we know, will look something like this. The next thing we're going to look for is the y-intercept, okay? So our y-intercept of this equation. Now, when we're looking for a y-intercept, we always know what the x value is, and we're actually searching for the y. Can anyone tell me what x is equal to? at the y-intercept? 0. So our y-intercept always has an x value of 0 because that is where our parabola is going to cross this point. We know that this point is always when x is equal to 0. Okay? So in other words, what we can do is we can plug in 0 into our equation for all of our x variables. So we're going to rewrite that equation. We'll go to the next page. So we have our equation, and we know, again, at our y-intercept, we know our x value will be 0. We're searching for a y. So, in other words, our x, or in this case, the variable is represented by w. We can replace w with the number 0, and we know f at x is going to stand for our y. So, in fact, what I'm going to do is I'm going to replace my f at x with a y, and I'm going to replace the w with an x, so that we can relate it to a graph. So our equation with xy as the variables is y is equal to negative bracket x minus 20 squared plus 400. We're going to plug in the number 0 for x, and then we're going to solve for our y. So y is equal to negative 0 minus 20 squared plus 400. Okay? When we go to equate this, 0 minus 20 is negative 20 squared plus 400. What is negative 20 squared? 400. Okay? It's a negative times a negative. So we're going to get positive 400 plus 400. There's a negative sign in front of this. So when we go to distribute it, what's going to happen? What is it? Negative 400 plus 400. So it turns out that our y-intercept is 0 and 0. In other words, the origin. So we go back to our graph. We're going to change what we've drawn, our estimation, just a little, because we know that this graph, we know that the y-intercept is exactly at the origin, 0 and 0. Okay, let's see if we can find the other ones. So that was our y-intercept. The next thing we're going to solve, we found the y-intercepts. I'm going to look for the x-intercepts from vertex form. So same idea with our x-intercepts. Let's quickly go back to our graph. We know that this is a graph facing downwards, and luckily we've actually already found one of the x-intercepts. But we know because the vertex is above the x-axis and it's facing downwards, how many x-intercepts are we going to have? 2. We're going to have 2. So we have to keep sense of that when we're going through the math. An x-intercept is the same idea, only difference is this time we're looking for an x value. What is our y value? 0. So it's the opposite of what we were doing before. Again, we're going to change this equation. We're going to replace f at x with y and w with x. So we still have the same equation. We just want to relate it to our x, y coordinates. This time we're going to plug 0 in for our y value. So we'll have 0 is equal to negative x minus 20 squared plus 400. Okay? Now, what it is I need to do is I need to isolate x. I need to solve for it. So I got to go through my algebra rules. I'm going to take 400 and move it to the other side of the equation. When I do that, it becomes negative 400 on the other side is equal to negative x minus 20 squared. Okay? Now think of this like reverse bed mass. Normally we have because we're trying to isolate our x, let's think of it like we were dealing with the addition and subtraction first. We're doing reverse bed mass when we're trying to isolate a variable. So I dealt with the addition first and I moved it to the other side. The next thing I need to deal with, there's no other subtraction. So what's the next pairing? Division and multiplication. Do you guys see any multiplication in here? This negative 1 is multiplied by these brackets. Okay? Now I know the 1 isn't written in there, but we assume the number 1 is there. So, in other words, because that's multiplied by negative 1, and we're going to write the negative in so it makes sense to you guys. We have negative 1. I'm going to need to divide both sides by negative 1 so that they cancel each other out. When they cancel each other out, we're going to be left with x minus 20 squared. And when I divide negative 400 by negative 1, I'm going to get positive 400. Okay? Okay? Now that we've done that in our reverse BEDMAS, we dealt with the addition and subtraction, division, multiplication. What's next in our order? What's the E in BEDMAS? Exponents. We have an exponent, and I need to deal with it. In other words, I need to get rid of it. So to get rid of the power of 2, I need to square root both sides. Okay? Yeah, you can say there's a 1 in front of x. So we've square rooted both sides. What's going to happen is the square root on the right side and the power of 2 will cancel each other out. And we're left with x minus 20. And the square root of 400 is 20. But there's one other thing. There are 2 answers to that. There is 20 positive and there is 20 negative. Okay? If I multiply negative 20 times negative 20, I will get 400. And if I multiply positive 20 times positive 20, I will get 400. So I actually have 2 answers now. When I square root of 400, I have positive 20 and negative 20. So what I want you guys to do from this point is we're now working with 2 equations. We're working with positive 20 is equal to x minus 20. And we're working with negative 20 is equal to x minus 20. Because there are 2 answers to 400. So we split this equation up, but what we needed to do is we still need to isolate for x, okay? Now these brackets, they're no longer important. There's nothing outside of them, so we're going to take them away. We still have positive 20 is equal to x minus 20, and we have negative 20 is equal to x minus 20. So we're working with 2 answers now. When I bring 20 to the other side, I'm going to get 20 plus 20 equals x. And on this side, I'm going to get negative 20 plus 20 equals x. So I have 2 answers for my x-intercepts, which makes perfect sense because we said there was going to be 2 x-intercepts. One of the x-intercepts is going to be at 0 and 0. We already solved that. We already know that y is 0. And the other x-intercept will be at 40 and 0. So when we go back over to our graph, one of the x-intercepts was at 0 and 0. The other one was at 40 and 0. Okay, so say we have a vertex above the x-axis. Here's our x and here's our y. Not as nicely drawn as before. Okay, but it's opening upwards. How many x-intercepts am I going to have in this question? There are 0 x-intercepts. How many y-intercepts will I have? 1 y-intercept. It's going to be farther up, that's right. These are our x and y. We know it's eventually, at some point, going to pass the y-axis. Okay? Let's do another one. Actually. Yeah. The same idea happens here. If we have a vertex below and the parabola opens downwards, we'll have 0 x-intercepts because it won't cross the x-axis, and we'll have 1 y-intercept. Let's say we have, same idea, we have a vertex up here and it opens downwards. How many x-intercepts do I have? And if I have one below and it's opening upwards? 2, okay? So in these examples, we have 2 x-intercepts. How many y-intercepts? Still just one y-intercept. And finally, the very rare case, no. If our vertex is on the x-axis, that means the vertex is right on it, and it doesn't matter which way it opens, we will have one x-intercept. Okay? So this is when the vertex is right on it. It touches it once. So we have one x-intercept. How many y-intercepts? Still just one y. This is every single case possible with a parabola. All right, we're going to do example 4. And I'm going to give you the general idea of what we're going to be doing throughout this question. We're going to go from vertex form to standard form to factored form. In fact, all three of these forms are related to each other. We're going to go through the process of starting in vertex form. And the point is we want to find what our x-intercepts are. So we have to move to standard form and then into factored form. So we have our question, f at x is equal to x minus 5 squared minus 36. So in order to get to standard form, what I need to do is I need to expand and simplify. So in order to expand and simplify, if you guys remember, we have a bracket as the base and 2 as our exponent. So in other words, we need to repeat this bracket twice. So we're going to move it over a little. F at x is equal to x minus 5 times x minus 5 minus 36. I'm going to use either FOIL or the rainbow method. You guys can choose. I'll quickly do the rainbow method for you. So when we do x times x, we get x squared. And x times negative 5 is negative 5x. Negative 5 times x is negative 5x. And negative 5 times negative 5 is positive 25, still minus the 36. We're going to simplify our brackets. We get x squared minus 10x plus 25 minus 36. Now I can't simplify these brackets anymore if we look at BEDMAS. All three of these are different terms. So this is as simple as these brackets get. So I'm going to drop the brackets and I'm going to collect like terms. So I get x squared minus 10x plus 25 minus 36. The only two like terms I have are my constant numbers. So I get x squared minus 10x minus 11. And now I'm in standard form. Okay, now from our standard form, in order to find our x-intercepts, we need to factor this. Okay, so we take that same equation, x squared minus 10x minus 11, and we use our factoring method. We find the factors of our coefficient, which are 1 and 1. And remember, technically, 1 times 1 won't give us 1x squared. Technically, there are x's here. Okay, and it's 1x times 1x. I then find the factors of our last term, 11, which are 1 and 11. Let's do it this way. Okay? We're going to multiply, and their products need to add up to our middle term, which is negative 10. And again, technically there's an x there, so we're going to say 10x. But as long as you got the numbers right, you were fine. So we trial and error here. We do 1x times 1 and 1x times 11. We're going to get 1x and 11x. This combination we know is going to work. But the 11 will need to be negative in order to get negative 10x when we add these. So in other words, the number we multiplied, which was the 11, has to be negative. In order to make sure that works, we got to check, does negative 11 times positive 1 equal negative 11? Yes. So we know it works. So we're going to put it in our factored form. Our first column are going to be the first terms in the brackets, which are 1x and 1x, or just x and x. And now, normally we have to put them in opposite brackets. So 1x was multiplied by positive 1. So the x and the positive 1 go in opposite brackets. And our 1x times negative 11 were multiplied by each other, so we have to put them in opposite brackets. Now, if you notice, it doesn't make a difference because both the first terms were the same. So our factored form was, in fact, x minus 11, x plus 1. So, finally, I'm trying to find the x-intercepts. That's when y needs to be 0. We do know that. We've got to find the x value. So we're going to plug 0 in for y. So I'm going to split this. We get 0 is equal to x minus 11, and 0 is equal to x plus 1. When I move the 11 over, I get positive 11 equals x, and I get negative 1 equals x. So my x-intercepts are negative 1 and 0, and positive 11 and 0. Now, I know you guys know how to go to find the axis of symmetry in Vertex using these, but because we came from Vertex form, we already know what the vertex is going to be by looking at our h and our k. We know that our vertex, the x value will be opposite of the h, so positive 5, and whatever the k is, negative 36. So we already have our vertex, and we have our x-intercepts. So we're going to put this on the graph now. We had our x value and our y value. We'll go back to the other page. Our vertex was at 5 and negative 36. Okay, so let's say this is roughly 5. I'm not putting this perfectly to scale. And this is negative 36. So our vertex is here, 5 and negative 36. And our x-intercepts, we found at the bottom, were 11 and 1. Sorry, negative 1. So negative 1, and we'll say this is 11. So our parabola does something similar to this. 11 and 0, and negative 1 and 0. So we found the x-intercepts, the vertex. There's one last thing I can find, which will be a y-intercept. Okay? But the fastest way to find the y-intercept is actually when we're in standard form. So we're going to jump back quickly, and we'll calculate it on the side. We've gone from vertex to standard. I forgot to write it at the bottom. We were in factored. This is our factored. Okay? When we're in standard form, to find a y-intercept, we need our x values to be 0. Okay? So I'm going to do it in red on the side. Y is equal to x squared minus 10x minus 11. To find a y-intercept, our x value is 0, and we're looking for the y. So when we plug in 0 for our x's, we're going to get 0 squared minus 10 times 0 minus 11. What's going to happen to those zeros? They're all going to cancel out. We know that y is equal to negative 11. So standard form is the easiest way to find a y-intercept. Okay? So when I go back, my y-intercept's at 0 and negative 11. So we know that this point here is at 0 and negative 11. So we found all the major points along this parabola.